This is easy. What's the domain? X is greater than or equal to 2. Everybody's got that, right? Nobody's going to miss that one. List all the graphs shown that are even. So I've given you 4 graphs. These are 4 of your, basic functions. Which ones are even? Now, you don't have equations to these, and you should know what the equations are, but you don't really need the equation if you just remember, what does even mean? What does even mean? If a function's even, what does that mean? Symmetric about the y-axis, which means if you folded your paper on the y-axis, it would double over on itself, right? Look at graph A. Is that symmetric about the y-axis? Absolutely. Look at B. Symmetric about the y-axis? Yes. Yep. C. No. Be careful. If you were symmetric about the y-axis, wouldn't it look like this? And it doesn't. So that one's not. What about D? No. No. If D were symmetric about the y-axis, well, I don't know. It would look like that, I guess. I mean, you wouldn't have that branch down there, so it's not. So the only two that are symmetric are A and B. Which is the absolute value graph? Well, this was on your quiz yesterday. B. Which basic graph is D? Use words or an equation, so you have to know both. So what is it? That's your cubing function. And the equation would be y equals x cubed. And then there's a bonus question down there. What impact does the 2 have in the equation x minus 2 squared? 2 units to the right. Remember, when numbers are attached to the x, it's the opposite of what you think. This looks like a negative, but it actually moves it 2 units to the right.
When it says like x minus 2, x minus 2 squared, do we just like leave it like that and just plug it into our calculator like that?
Yeah. Now I expect you to be able to do that without a calculator.
Yeah.
Okay, turn it over. Turn it over. Let's do this real quick. List the intercepts, and I put in parentheses points because it's important that we recognize the intercepts are ordered pairs, the asymptotes are equations, right? You will lose points if you don't get these straight. You got to remember your intercepts are ordered pairs. They are points on the graph. The asymptotes are lines, so they're equations. All right, so we're finding the intercepts. Okay. How do we find intercepts? Plug in 0 for each variable. So your x-intercept will be found by letting y be 0, and your y-intercept will be found by letting x be 0. So that was the easiest one. So let's plug 0 in. What do I get when I plug in 0 for all my x's? 6. So my y-intercept is 6. Good. Now I'm going to let this be 0, right? So I'm going to multiply this over to here, and what happens? It's gone. So don't I just have this?
Yeah.
So I'm going to factor that, and that factors as, that's a quadratic equation. So you can use whatever you want. It happens to factor, so minus 4 plus 3. So what are my x-intercepts? I'm actually going to have 2 of them, aren't I? My x-intercepts will be 4 and negative 3. Okay, so I've got some funky graph drawn here. What is the domain of this curve? All real numbers. Goes forever and ever, x horizontally. What is the range? Y is less than or equal to 3. Is it bounded above?
Yes.
By 3. Is it bounded below?
No.
No. Does it have any zeros? What are zeros? X-intercepts, points on the x-axis, x-intercepts. So it has a couple of zeros. They are points. What are they? Negative 1, comma 0, and 3, comma 0. Does this function have any intervals on which it is increasing? Remember, we're talking about moving left to right. So if you traced over this picture, would your pencil ever be going up?
Yes.
Yes. Starting where?
Negative.
Negative infinity to what? To 3. Negative 3, I'm sorry, x values, negative 3. So you're going up until you get to negative 3. And then what happens when you get to where x is negative 3? It levels off for a little bit. Then all of a sudden it starts going back up again, doesn't it? Where does it start going back up? From negative 2 all the way until it gets to 1.5. Remember, we're looking at x values. We're looking at x values. We're talking about the intervals, not the height, but the actual intervals. What would number 3 look like? This should take you like 4 seconds. It's, what shape is it? A V? And? Up 1. How do we know it's up 1? Because the 1 is attached out here, not in here. What happens when you attach the 1 in here? Move it to the left 1. This one goes up 1. Number 4, find the removable discontinuity. What's that another word for? Holes. So how do we approach that? How do we do that? We factor. So we are going to factor out. So let's see. It looks like the same numerator I had before. And my denominator. So what's going to cancel? X plus 3, which tells me my whole will be where x is negative 3. That's what canceled out. That's what makes this 0. So then what do? And I plug it into x minus 4 over x minus 3. So that would give me negative 7 over 7/6. Okay, tomorrow we will have a quizzy-poo solo, no speed dating, no table work, solo quiz tomorrow, and it will be over everything up to what this, 1.3. Okay, so we've done some practice quizzes. We took a quiz yesterday. This is what you have to know. So don't walk in this room tomorrow without knowing your 12 basic functions. Okay, I am going to cut you a little bit of slack. I am going to take, for the time being, the logistic function off the table. That one is a little bit complicated. We haven't had time to talk about it very much. So basically you have 11 functions, not 12, which you're responsible for. Okay? We're going to do the logistic function. We're going to write equations for the logistic function. But we haven't had time to talk about it. We need to put it on a quiz yet. Okay, so everybody clear on that? You can do these practice quizzes that we've had handed out. You should be okay. All right. Oh, hey, while we're at it, I gave you one more. Let's do it too. There's one that says Precal A period 5 dominates. Looks like this. It has symmetry on the front of it. Yeah, that's it. It says test of symmetry at the top. All right, so here we go. Determine about which of the following we have symmetry and show your work. Okay, so this requires you to remember the tests of symmetry. This is good review. Bear with me. Okay, so here we go. What is the test of symmetry for the x-axis? Make the y's negative. Good. So if we did that, so the work I need to show would be this. That's the work, right? Now, is that a yes or a no answer? No, because if you're going to have symmetry, what you get when you make the sign change has to be the same as the original. Are these the same equation? No, so that's a no. What's the test for y-axis? So that would look like this in terms of work. Now what happens here when you simplify this? It's the same, so that is a yes? Oh, sorry, there's a 2 there. That hasn't changed anything. Okay, origin. What's the test for the origin? Change them both. Now, when you simplify, this cancels, right? This does not. So does that leave me with the original equation? Nope. How about y equals x? What's our test there? Flip them. So you'll have x equals 2y squared? Clearly, that's not the same equation. Because that curve has symmetry about the y-axis, it is called what kind of a function? Even. Okay, let's do the same thing here. Don't you dare act bored. This is good review. Gotta be able to do this tomorrow. Maybe.
How do you know if it's odd or even again?
Definition. Even means symmetric about the y-axis, odd means symmetric about the origin. Okay, x-axis. What's our test for symmetry again for the x-axis?
Make y negative.
Make y negative. And then stand back and look at it and say, that is not the same equation. How about x or y-axis?
Well, make x negative.
Make x negative. And that is not the same equation. Origin?
Make both negative.
Now be careful with this one. Sometimes you think these are going to be the same because you're going to divide out that negative, but be careful. When you divide out the negative, what happens here? That becomes a minus, and therefore they are not the same. And then y equals x? And clearly that's not. So that one has no symmetries. And this is the kind of work I would need to see, right? No points for guessing. Okay, is y equals negative x odd? Why or why not? Well, you need to do what? If you want to know about y equals negative x, you're going to do the test of symmetry for the origin. So that would be negative y equals negative x. Same equation when I simplify it?
Yes.
Yeah.
When they're referring to odd, does that mean it's not symmetric?
Because you.
Odd means it has symmetry about the origin. That's the definition. Odd means it has symmetry about the origin. So if somebody wants to know if it's odd, we do the origin symmetry test.
So then, if it's even, it's just symmetry over the y.
I know I talked about that because I always make a big deal about origin odd. Okay, backside. Quickly, we got some stuff we're supposed to be doing today. Identify the following with words or an equation. What's that first one?
Natural law.
That's your logarithmic function, right? Y equals ln x, or the logarithmic function. These words, it's the logarithmic function, or you can write the equation y equals ln x. What about b?
Squaring.
That's a squaring function, or y equals x squared. What about c?
Reciprocal.
It's the reciprocal function, or y equals 1 over x. Now, how do I know those? I memorized them, right? Put them on flashcards if you need to. Get them memorized. Okay, number 2. List the domain and range of the absolute value function. Now, I actually set up a grid for you because I think if you look at the picture, it's easier for you to tell. What's the domain? All reals. What's the range?
X.
Y is greater than or equal to 0. So your domain is all real numbers. Your range is y is greater than or equal to 0. Even functions have what symmetry? Over the y-axis. Name any one of your basic functions with the following end behavior. Now, what this means is, what this end behavior stuff means is simply, as the picture goes, this says, as x becomes bigger positive, the function becomes bigger positive. So what does that mean? That means as you go this way, you go that way. So it has that, somehow that kind of behavior. Going to the right implies going up. And then going to the left, x approaches negative infinity, that's left. The function is going where? Down. So you need some function that has that kind of behavior. Now, one of them, obviously, from the way I drew it, one of them would be the identity function does that. But that's not the only one. Think of your cubing function. Doesn't your cubing function do the same thing? So those are the first two that come into my mind. This would not come into my mind. Because why? What's wrong with this one? That part's right, but this part goes positive, and the directions say it's supposed to go negative. So that wouldn't fit this. What would the end behavior of this one be? The limit as x goes to the right is positive, and the limit as x goes to the left is positive. So any curve with that kind of shape would have this end behavior. Positive on this side, positive on this side. This one is positive on the right, negative on the left. So two of them, there may be others, these are the first two I think of. Two of them would be right here, right? And 5, your good old domain question, what's the domain of that function? X is greater than or equal to -1? Okay. So if you know all the stuff that's been on those old quizzes, you are good to go. Tomorrow's quiz will not have a regression on it. Tomorrow's quiz will be done with no calculator. If you want to touch, everybody hear me say that? Tomorrow's quiz is no calculator. Now, I want to do a couple of quick things, and then we'll hit some homework questions that you have. Because I know you've got a lot. They're accumulating from yesterday and so on, so we'll get those. We're going to touch base real quick about putting functions together. This is not a complicated idea, but the way they do it in the book, it seems a little complicated, so I just want to make sure you're clear on what you're doing. Let's say we have a couple of different functions. F of x is 2x and g of x is x squared minus 4, we'll say. Take that, a couple of different functions. Could we add these functions together? Well, of course we could. We would have 2x plus x squared minus 4, which I would probably put in descending order. That would be the sum of those two functions. Kids, not hard. Common sense. It says add them together. Okay, I'll add them together. If it said f of 2 plus g of 3, you could do that too, couldn't you?
Yeah.
What's f of 2?
4.
4. What's g of 3? 5. So the answer would be 9. So we can add them together in their general form, or we can add them together with they have specific input values. Do you think we could do the same thing with subtraction?
Yeah. No.
Yep. Multiplication? Yep. Division? Yep. Easy. Don't make it hard. If they say add them together, add them together. Now, this means something else though. That's a little open circle. Do you remember seeing that notation?
Yeah.
Which sometimes is this notation. Sometimes there's no open circle. Sometimes it's just like brackets there. What does that mean? That is not add, subtract, multiply, or divide. That is,
I don't know the name, but you plug G into F.
so it literally says, if you were going to say it out loud, you would say F of G of X. So you're right. You plug G into F. This is called composition, function composition. So we talk about finding the composition of functions. We mean plugging, like Maggie said, plugging one into the other one. Okay? So if we were going to use my functions and we were going to find f of g of x, think about that for a minute. That would be f of x squared minus 4.
It'd be 2.
Because g is x squared minus 4. Now I'm going to plug that into my f function, and remember how that works. Whatever you plug in place of x. So that would be 2 times x squared minus 4, or 2x squared minus 8. Now, I don't know if we just have the Wednesday woes, or if we're bored out of our minds, or what. Look alive. Let's try g of f. Let's do it in the other order. Now this is the other order. This is not the same thing. This says find g of f of x, which means I'm going to plug 2x, which is f. I'm going to plug 2x into g. So what's that going to look like?
2x squared
2x quantity squared
minus 4.
minus 4. Which is 4x squared minus 4. Notice, did we get the same answer?
No.
No, it's not commutative. It matters what order you do it. This says plug f into g. This says plug g into f. Let's try another one, see if you got it. You did this last year, so this should be better. Let's say a of x equals 2x squared minus 3x, and b of x equals 1 over 4x. Okay, here are our functions. Can you find a of b of x? Okay, now what does that mean in words? What am I supposed to do? Plug b into a. So every time I see an x, I'm going to plug b into it. So that's going to be 2 times 1 over 4x squared minus 3 times 1 over 4x. Now take a look at that. If you're confused, sit back and look at it. You're plugging b, which is right here, that. You're plugging that into a. So this would be 1 over 16x squared. And the 2 and the 16 will cancel. Remember, these are fractions times each other. So 1 over 8x squared minus 3 over 4x. We'll just stop right there. Now on your own, do the other order. And compare notes with your neighbor. So do b of a of x. Compare notes with your neighbor. hopefully you got this. Is that what you got? Because you took A and plugged it in right here, plugged it into B. All right, one more, and then we'll look at some homework questions. One more. Same two functions. What if I said find A of B of 4? I don't want to do 4. Let's see, 2. What if I said find A of B of 2? What do we do there? Plug 2 into B, so that would give me 1/8, right? And then take the 1/8 and plug it into A?
Yeah.
So that would be 2 times 1/8 squared minus 3 times 1/8. So that would be 1/32 minus 3/8. Oh geez, wouldn't you know I have fractions? Negative 11/32 if I get my common denominator. Okay? Now, they're going to ask you to do some compositions tonight, and they're going to ask you about the domain. You know the rules for domain. For example, look at these two functions. What's the domain of A? All real numbers. What's the domain of B?
Negative.
Everything except 0. Everything except 0. Can't be 0 down there. You can be 4. 4 is not a problem. Negative 4 is not a problem. 0 is a problem. Right? Now that means that any problem you do that involves function B, you can't use 0. So if they say, okay, build the composition, what's the domain of the composition? It's still going to be x can't be 0. You're never going to be allowed to have x be 0 in any problem using function B. Got it? Okay. All right, so how about homework? What homework questions do you have? Got a few minutes here to talk about that, clear that up. Tonight's homework hopefully will be a little easier for you. Quiz does not have any of this composition stuff on it. The quiz will be just what we, our basic functions and that kind of stuff. Remember, the quiz is on your own now. Make sure you know this stuff. You won't have your friend to help you.
Can you explain the extreme?
High points and low points, that's it. The critical values, yeah, high points and low points. So maximums and minimums. Okay? Who else has a question about a homework problem? Harry Payton. Whose phone is that? Well, just turn it off, whoever's it is.
Check for like a reason.
Okay, so no questions at all about all this homework from the last few nights. Okay, I hope we're doing our homework. Yes, Maggie?
When I was going through each, for exercises 35 through 42, when it asked like the A.
Okay, you're in 1.3.
Yeah.
We're looking at, let's just pick 35, okay?
Yeah. So, I got really confused on how to determine each one.
Okay, don't be confused. R of x, I'm looking at 35. R of x is what, I know it's got other stuff in it, but what basic function are we talking about when we see this problem right here? What basic function are we talking about? The square root function. Now, what does the square root function look like? Okay, so that's part of our issue. This is the square root function. It looks like this. Okay? Now, this one, though, has this stuff stuck in there. So what does that do to it now? Moves it which way? Right 10. So this would be the point 10, 0. Instead of 0, 0, which is where it's supposed to start, it's been shifted over here. But that's your square root function shifted 10 units to the right. Once I have that picture, and I don't need a calculator to do that, you're not gonna have a calculator tomorrow. You need to know a square root has this shape, and then you need to know what the minus 10 does. So then you've got it. Now you can answer the questions. On what interval, if any, is the function increasing? 10 to infinity. The whole thing's increasing, isn't it? So then the second part of that says, on what interval is it decreasing? It isn't. This function doesn't decrease. Is it odd, even, or neither? Well, you can tell from the picture that it doesn't have any symmetry. Because if it had symmetry, it would have to have a piece over here or a piece down here somewhere, right? And it doesn't. So it's not even or odd. It's neither. Now, if you want to go ahead and do your tests and plug in your signs, you absolutely can. But since you have a graph, you can use that too.
So if it's even, then it's like it crosses over like this way down below over the y, or no, this way. But if it's not even, then it's not odd. It's just not symmetric over the y-axis.
Right.
Okay.
Right. Right. Even, it's not like numbers where you're either even or odd.
Okay.
Functions can be either.
Okay.
How do you write out like how do
You say it's increasing on the interval from 10 to infinity. It asks you for the intervals. What's going on here?
Oh, I have nothing.
Okay. All right, and then the next question is, give the functions extrema, if any. So your extrema are your maxes and min. So you could say this curve has a minimum at 10, 0. And that minimum would not only be a relative or local minimum, but it's also the absolute minimum. That is the lowest point. How does the graph relate to the graph of one of the 12 basic functions? It is this exactly, but shifted 10 units to the right.
So like when it asks for D, it's how it relates. So does it relate to its original one, like without any numbers or anything?
Yeah, these are the 12 basic functions, no numbers in them. All right. Who else had a question about something? Emma? Oh shoot, I forgot we have a little bit short periods today. All right, tomorrow we have a quiz. Do your homework. Have a good day. Protein bar, is that breakfast this morning?